In this problem, we are asked to determine the oxidation number for each element in the following compounds. The rules for determining oxidation numbers are discussed in your textbook. There are some rules that have to do with the sum of the oxidation numbers adding up to 0 for compounds, neutral compounds, or adding up to the ionic charge for ions. There are other rules that assign specific oxidation numbers to oxygen and hydrogen and halogen compounds and various others. I expect that you will be familiar with those rules in order to proceed on this problem. So let's look at number A, scandium oxide. In this case, the rules say that the oxidation number of scandium times 2 scandiums plus the oxidation number of oxygen times 3 oxygens equals 0, because this scandium oxide is a neutral compound. So we can say oxidation number of scandium times 2 plus oxidation number of oxygen times 3 equals 0. Oxygen is one of the oxidation numbers that's covered in the rules, and in ionic compounds, with the exception of peroxides, the oxidation number of oxygen is -2. So we can say then that the oxidation number, 2 times the oxidation number of scandium plus 3 times -2 is equal to 0, and therefore the oxidation number of scandium is equal to 6. And we take this -6 over on the right side and change the sign, divided by 2, and this will be +3. The oxidation number of oxygen in this compound will be +3. If we look at gallium chloride, we approach it the same way. This is a neutral compound, so we can say the oxidation number of gallium plus the oxidation number of chlorine times 3 is equal to 0. Now, this is an ionic compound containing chlorine, so the rules say that oxidation number of chlorine under these circumstances will be -1, the chloride ion. And we have to solve for the oxidation number of gallium. So oxidation number of gallium plus 3 times -1 equals 0, and oxidation number of gallium equals +3. Okay, so we put a +3 up here for the gallium. If we go to the hydrogen phosphate ion, we can write down the formula of the hydrogen phosphate ion from the name. It is HPO4 2-. Since this is a polyatomic ion, the sum of the oxidation numbers of the atoms involved has to add up to the charge on the ion, which is -2. So we can say the oxidation number of hydrogen plus the oxidation number of phosphorus plus the oxidation number of oxygen times 4, there are 4 oxygens here, equal to -2. The rules say in compounds like this that the oxidation number of hydrogen will be +1. So +1 plus the oxidation number of phosphorus plus 4 times the oxidation number of oxygen, which will be, as we saw above, -2, is equal to -2. So we have the oxidation number of phosphorus is equal to -2. And this will be 8, -8. We change sides. It's +8, -1. So that will be 8 minus 3, or +5. So in the ion, hydrogen is +1, phosphorus is +5, Oxygen is negative 2. Finally, in iodine trifluoride has formula IF3. This is a neutral compound. The sum of the oxidation numbers of iodine and fluorine, the three fluorines, has to be equal to 0. So we can say oxidation number of iodine plus oxidation number of fluorine times 3 is equal to 0. So the oxidation number of iodine plus 3 times, now fluorine will be negative 1 according to the rules. Fluoride ion, like the fluoride ion, it's not really the fluoride ion, but it'll have a negative 1 oxidation number. The sum of those will be equal to 0, so the oxidation number of iodine will be equal to positive 3. So positive 3, negative 1.